Hey guys, and welcome back. We are talking about our second transformation today, which is reflections. Our learning target is still to define, understand, and apply the rigid motion transformations, so the transformations that don't change shape and size. Today we're going to focus on reflections. We're going to define reflections, recognize it amongst other transformations, recognize reflections and their lines of reflection, and we're going to perform near arrow notation for these reflections just like we did for the translations. And we're also going to be able to describe in words how to reflect one pre-image to its image, as well as actually do the reflections ourselves. So let's take a look at the main idea here. It says a reflection or a flip, again that's our slang term, flip for reflection, is a rigid motion that flips a figure over a line called a line of reflection. If you notice in my picture, I have a dotted red line. That's going to be my line of reflection. So let's say if point A is on the line of reflection, so let's draw a point on the line, call it A, then the image, A prime itself is going to be on the same spot as A. Think about spinning that line of reflection as if it's a string. The point is still going to stay attached to it as much as you spin it. So really, A is in the same location as A prime. Okay? If I have a mirror image, it's kind of like you reaching out to the mirror, touching it with your finger. Your finger is just sitting on top of your fingertip. So let's try a different example of something that is not sitting on top of the line of reflection. Let's say if point B is not on the line of reflections, let's say out here, let's put B, then B and B prime are on opposite sides of the line of reflection. They are on a line perpendicular to the line of reflection and are on the same distance from the line of reflection. So what that all says is that in order to get B prime, you have to count how many units is B away from the line of reflection. So 1, 2, 3 units. Okay, if I were to draw a line to the line of reflection, it's 3 units long. Now I just need to draw the same distance, but on the opposite side of the line of reflection. So 1, 2, 3 units long. So that means B prime is right there. Okay, that would be a mirror image. Notice how the line that connects B and B prime, that looks like it's creating a right angle with the line of reflection. That is something we need to know in definition of a reflection, that the pre-image and the image form a perpendicular line to the line of reflection. So let's give this a try in example 1, just recognizing what a reflection is. So I should see a mirror image, not something that has been turned or spun, and not something that has been slid like a translation. Okay, so the first one that I see, it kind of looks like it's been spun. Okay, if I were to spin the black triangle onto the blue one, okay, I would have to turn it in order to get the points to sit the way that the shape to sit the way that it should. Also, I'm seeing that C would not correspond to C prime if I did spin it. It wouldn't land in the right spot. Also, if I tried to reflect the black triangle, A sits on A prime because it's 1 unit away. But then C is 1, 2, 3 units away from the y-axis, which is the line of reflection. But then C prime is only 2 units from the y-axis. Okay, they need to have equal distances in order for it to be a mirror image. So this one is not a reflection. I do see a reflection, however, in the second one. Notice from if we were to draw the line of reflection, so the line that sits in between the two mirror images, A is 1 unit away from the line of reflection, and so is A prime. C is 3 units away from the line of reflection, and so is C prime. And then B is 2 units away from the line of reflection, and so is B prime. So that one definitely is a reflection because they are equidistant from that line of symmetry. The last one I see is actually a translation. I see a slide happening here. So that one is not a reflection. let's have you give this identification a try in your first U try. Which graph shows the reflection of triangle DEF across the x-axis? Now I want to make a note that it does say the x-axis. We reflect it across the y-axis on this example. The x-axis, I'm going to highlight on all these pictures. Is this here a line of symmetry? Is this here the line of symmetry? And is this here the line of symmetry? So what I need you guys to do is pick the one that is a reflection, but it's reflected over the x-axis. Alright, I have another intro here for example 2. It says triangle A prime, B prime, C prime is the image of triangle ABC after a reflection across the y-axis. So if I highlight the y-axis, you can see that it is directly between the pre-image and the image. It has the pre-image and the image are equidistant from that line of symmetry. You can use arrow notation to show how each vertex of triangle ABC maps to its image after the reflection. Especially when we're reflecting across the x or the y-axis, you should be able to notice some patterns in the arrow notation. So if you look at this reflection, we literally just wrote down what the coordinates were from ABC and A prime, B prime, and C prime. Okay, so let's notice what's happening with these points here. Okay, so I'm actually seeing that to go from this x to this x, it looks like it just changes from negative to positive, whereas the y's, those stay exactly the same. I'm going to notice this again in B, from -3 to +3, and from -2 to +2, whereas all the y's from 2 to 2, that stayed the same, and -1 to -1, that also stayed the same. So whenever we reflect across the y-axis, it seems like the x values are going to become opposite. We can also say the opposite is true. If we were to reflect over the x-axis, the y's would just become opposite. So keep in mind this idea of using arrow notation, just like we did on the last lesson for translations, to help you notice patterns where points may be changing and you can make a generalized conclusion. Let's do another example here. It says PQRS, is a rectangle. Describe in words how to map PQRS to its image P prime, Q prime, R prime, S prime. Then use arrow notation to show how each vertex of PQRS maps to its image. Now this is not a reflection over an axis. I want you to draw in the line of reflection here. And when you draw in a line of reflection, you just want to draw a line that is directly between the pre-image and the image. If I were to place a mirror anywhere on this graph, I would say the mirror is right here. This line right there. It's not an axis, and we're going to practice naming that line. Okay, how can we name that line? Okay, in order to name, and I want you to take note, naming horizontal or vertical lines. Okay, there's a process for this. All you need is y equals a number or x equals a number. Okay, it's going to be y equals a number when it's horizontal. Okay, horizontal lines pass through the y-axis. So all of the y values are going to be that same number. Whereas if it's x equals a number, that's going to be a vertical line. Okay, because all of the x values of a vertical line are going to be the same. So since the red line that I drew, that's going to be the line of reflection, is vertical, it's going to be x equals. Now you just name the number that that line goes through. Well, this right here is going to be at 1 because it's halfway between 0 and 2. So this line is x equals 1. So if we're going to describe this reflection, we would say that it's been reflected over the line x equals 1. That's going to be our description. Okay, the last thing they wanted us to do was to show arrow notation. So I'm going to move my example up here, and I'm going to write my arrow notation just below. So I have P, which again, I'm just reading right off the graph. So P I'm seeing is at 4, 3. Q is at 2, 2. R is at 5, negative 2. And S, which is at 7, 0. Goes to, okay, put arrows in between them all. P prime, Q prime, R prime, and S prime. P prime moved to negative 2, 3. Q prime moved to 0, 1. Oh, and I think I made a mistake on Q. Yep, I can see it's not 2, 2. It's supposed to be 2, 1. I'm going to correct that. That's supposed to be 2, 1. I noticed that because when you reflect, they shouldn't move up or down. And if the y value changes from a 2 to a 1, that means it went down somehow. So I caught my mistake there. Okay, R prime is at negative 3, negative 2. And S prime is going to be at negative 5, 0. Okay, so notice in this example for the arrow notation, the signs don't just change. So if you reflect over an axis, one of the two signs is just going to change. If you don't reflect over one of the axes, it may be a little more difficult to see the pattern that is happening. So there's our second part of the answer. That's our arrow notation and then our description. Okay, those are the two parts of the answers we needed for this example. Let's have you give this a try in your second U try. It says LMNP is a parallelogram. Describe in words how to map LMNP to its image L prime, M prime, N prime, P prime. All right, I've got one last example for you guys. It says the vertices of triangle ABC are 1, 3, negative 2, 4, and negative 1, 1. Graph triangle ABC and triangle A prime, B prime, C prime, its image after a reflection across the x-axis. So first thing, I always tend to bold what my line of reflection is, which they say is the x-axis. The x-axis is right here. So I'm just going to bold it so that I know exactly where my mirror is. Now I'm going to plot my points down. A is at 1, 3. Make sure you label. B is at negative 2, 4. And C is at negative 1, 1. Connect your dots, make your triangle. So there's my original pre-image. And then it says we have to reflect it across the x-axis. So what you need to do, start your pencil on any one of the three vertices, then count how many units it takes to get to the x-axis. So I'm seeing 1, 2, 3 units to the x-axis. So now we need to count 3 units, but on the opposite side of the x-axis. So 1, 2, 3. So the path from A to A prime should look just like that. So now A prime sits right there. Make sure you label. Now you don't need to draw the blue line every single time. If you just want to count, like hopping your pencil from grid line to grid line, that's fine. Or you can draw the line in either way. So C is 1 unit away from the line of reflection, so it's got to be 1 unit away in the opposite direction. So that makes C prime right there. And then my last point that I'm seeing, B, we've got right there's the path. That's 1, 2, 3, 4 units long. 1, 2, 3, 4 units again, making B prime right there. Connect your dots. You should see a mirror image of the two triangles. So let's have you guys give this a try in your third U try. You have triangle JKL. You're going to reflect it across the y-axis. So before you start, bold the y-axis. Okay, so you know what your mirror is. What are the coordinates of J prime? Now, if you notice, the triangle is overlapping the line of reflection. That's okay. Whatever side the point is on, reflect it to the opposite side. All right, I've got 2 more questions for you just to make sure that you are closing this lesson and you completely understand what was going on. You're going to answer on your guided notes as well as in the open response on your Edpuzzle. If you're having any problems answering these 2 questions, please don't hesitate. Raise your hand. We can get you can get help from Ms. Svetlik or Ms. Doring on phrasing how you want your answer to sound. So double check your work and then you can move on. All right, that about wraps up our lesson for today. We defined reflection in the key concept. We recognize and distinguish reflections in the very first example. We also recognize different locations of lines of reflections. That would have been in example 1 and in example 2. And we also performed arrow notation for reflections. That was specifically in example 2. We described reflections of pre-image to an image. That was example 3. And then we're also going to really focus on the 6 success criteria. Tomorrow we're going to perform a lot of reflections. So go ahead and start your homework.